When installing a wireway under a raised floor, several factors must be considered to ensure a safe and compliant electrical system. Firstly, the wireway must be completely enclosed. This enclosure is critical for protecting the wires from physical damage, which can occur from foot traffic, equipment movement, or other activities under the raised floor. An enclosed wireway also helps to prevent potential fire hazards by containing any electrical faults that may occur. Secondly, select a wireway that is large enough to accommodate the number and size of wires being installed, along with any future expansion needs. Overfilling a wireway can lead to overheating and insulation damage, increasing the risk of electrical problems. Proper sizing ensures adequate ventilation and room for additional cables as needed. Several reputable brands offer suitable wireways for raised floor applications. Eaton-B line provides the B-65635, a 6-inch by 3.5-inch covered wireway that is a reliable option. Legrand Wiremold offers the MP-635, a 6-inch by 3.5-inch wire duct designed for similar purposes. Handuit provides the Panlane 650, a 6-inch by 3.5-inch wire raceway suitable for organizing and protecting cables. When considering square D options, it is important to note the intended use of each product. Wall duct is not suitable for raised floor applications as it is designed for wall-mounted installations. Trench duct can be used in raised floor applications, but it is not specifically designed to be flush-mounted in concrete. It is typically used in open areas where it can be bolted to the floor. Therefore, ensure the chosen wireway is appropriate for the specific environment and mounting requirements of the raised floor. Several installation considerations are crucial for a successful and safe wireway installation. 1. The wireway should be adequately supported along its length to prevent sagging and damage to the wires. Use appropriate supports and mounting hardware to ensure the wireway remains stable and secure. 2. Provide access points to the wireway for easy maintenance and future upgrades. These access points allow electricians to inspect, repair, or modify the wiring without having to dismantle the entire system. 3. Label the wireway clearly to indicate the contents and location. Proper labeling helps to identify circuits and prevent confusion during maintenance or troubleshooting. 4. Connect the wireway to the electrical grounding system to ensure safety. Grounding provides a path for fault current to return to the source, reducing the risk of electrical shock. In addition to these considerations, there are additional tips to enhance the safety and functionality of the wireway system. Consider using a wireway with removable covers for easy access to the wires. Removable covers simplify maintenance and allow for quick changes or additions to the wiring. Use a wireway that is Underwriters Laboratories listed and meets industry standards. Underwriters Laboratories listing ensures that the wireway has been tested and certified for safety and performance. Consult with an experienced electrician for professional guidance and installation. A qualified electrician can assess the specific needs of the installation and provide expert advice on selecting and installing the appropriate wireway. Choosing the correct type of wireway involves understanding the environment it will be placed in, whether it's a wall-mounted application or under a raised floor. For wall-mounted applications, a wall duct is typically used. However, for raised floor applications, other options such as trench ducts or wire raceways are more suitable. It's important to consider the design and intended use of each product to ensure it meets the specific requirements of the installation. Wireways and ducts come in various sizes, and selecting the right size is crucial. The size should accommodate the number and size of wires being installed, with some extra space for future expansion. Overfilling a wireway can lead to overheating and potential damage to the wires, so it's always better to choose a slightly larger size. Proper support is essential for wireways and ducts to prevent sagging and damage to the wires. Adequate support should be provided along the entire length of the wireway using appropriate mounting hardware. This ensures that the wireway remains stable and can withstand the weight of the wires. Access points should be incorporated into the wireway system to facilitate easy maintenance and upgrades. These access points allow electricians to inspect, repair, or modify the wiring without having to dismantle the entire system. Clear labeling is crucial for identifying the contents and location of the wireway. Proper labeling helps prevent confusion during maintenance and troubleshooting and ensures that the correct circuits are identified. Grounding is a fundamental safety requirement for wireways and ducts. Connecting the wireway to the electrical grounding system provides a path for fault current to return to the source, reducing the risk of electrical shock. It's important to follow the National Electrical Code, also known as the NEC, guidelines for grounding to ensure safety. Wireways with removable covers offer convenience and easy access to the wires. Removable covers simplify maintenance and allow for quick changes or additions to the wiring without having to disassemble the entire wireway. Underwriters Laboratories listing indicates that the wireway has been tested and certified for safety and performance. Using Underwriters Laboratories listed products ensures that the wireway meets industry standards and is safe to use. Consulting with an experienced electrician is always a good idea, especially for complex installations. A qualified electrician can assess the specific needs of the installation and provide expert advice on selecting and installing the appropriate wireway. The National Electrical Code, specifically Article 376, covers the requirements for metal wireways. Article 386 covers requirements for surface metal raceways and surface non-metallic raceways. These articles provide detailed information on the installation, support, and grounding of wireways and raceways. Article 392 covers cable trays, which are often used in industrial and commercial applications to support cables. While cable trays are not enclosed like wireways, they provide a convenient way to route and manage large numbers of cables. The choice between a wireway and a cable tray depends on the specific requirements of the installation. Wireways offer better protection for the wires, while cable trays provide more flexibility and are easier to modify. The ampacity of conductors in a wireway is governed by NEC Table 310.15b3, which addresses adjustment factors for more than 3 current carrying conductors in a raceway or cable. When multiple conductors are installed in a wireway, the ampacity of each conductor must be derated to prevent overheating. The derating factors depend on the number of current carrying conductors and the ambient temperature. For example, if there are more than 3 current carrying conductors in a wireway, the ampacity of each conductor must be reduced to 80% or less of its rated value. This derating is necessary to prevent the conductors from overheating and potentially causing a fire. Proper ventilation is also important to prevent overheating in a wireway. Wireways should be installed in locations where there is adequate airflow to dissipate heat. The NEC requires that wireways be installed in a neat and workmanlike manner. This means that the wireway should be properly supported and the wires should be neatly arranged and secured. The wireway should also be free from sharp edges or other hazards that could damage the wires. It is important to avoid overfilling a wireway, as this can lead to overheating and insulation damage. The NEC specifies the maximum allowable fill for wireways, which is typically 40% of the cross-sectional area. This means that the total cross-sectional area of the conductors and cables in the wireway should not exceed 40% of the total cross-sectional area of the wireway. When installing a wireway, it is important to use the correct fittings and connectors. The fittings and connectors should be compatible with the wireway and should be properly installed to ensure a secure and reliable connection. Fittings and connectors should also be Underwriters Laboratories listed to ensure that they meet industry standards. Wireways are typically made of metal, such as steel or aluminum. Metal wireways provide excellent protection for the wires and are suitable for use in a variety of environments. Non-metallic wireways are also available, but they are typically used in less demanding applications. The choice between a metal and non-metallic wireway depends on the specific requirements of the installation. Grounding bushings are used to connect the wireway to the electrical grounding system. The grounding bushing provides a secure and reliable connection between the wireway and the grounding conductor. Grounding bushings are typically made of metal and are designed to be installed on the end of the wireway. When installing a wireway in a wet or damp location, it is important to use a wireway that is suitable for wet locations. Wet location wireways are typically made of corrosion-resistant materials and are designed to prevent water from entering the wireway. The NEC specifies the requirements for wireways in wet locations. When installing a wireway in a hazardous location, it is important to use a wireway that is approved for use in hazardous locations. Hazardous location wireways are designed to contain any explosions or fires that may occur inside the wireway. The NEC specifies the requirements for wireways in hazardous locations. When selecting a wireway, it is important to consider the type of conductors that will be installed in the wireway. The conductors should be compatible with the wireway and should be properly sized for the application. The NEC specifies the requirements for conductors in wireways. When installing a wireway, it is important to follow the manufacturer's instructions. The manufacturer's instructions provide detailed information on the installation, support, and grounding of the wireway. Following the manufacturer's instructions ensures that the wireway is installed correctly and safely. Regular inspections should be performed on wireways to ensure that they are in good condition and that there are no signs of damage or deterioration. Any damage or deterioration should be repaired promptly to prevent potential safety hazards. When performing maintenance on a wireway, it is important to disconnect the power to the wireway before beginning work. This will help to prevent electrical shock. Lockout/tagout procedures should be followed to ensure that the power remains off while the work is being performed. The tools and equipment used to install and maintain wireways should be properly insulated and grounded. This will help to prevent electrical shock. The personnel who install and maintain wireways should be properly trained and qualified. This will ensure that they have the knowledge and skills necessary to perform the work safely and effectively. The use of appropriate personal protective equipment, also known as PPE, such as gloves, safety glasses, and hard hats, is essential when working with wireways. This will help to protect workers from potential hazards such as electrical shock, cuts, and bruises. When working with wireways, it is important to be aware of the potential hazards associated with electricity. Electricity can be dangerous, and it is important to take precautions to prevent electrical shock. Always treat electrical equipment with respect and follow safety procedures. Consider the long-term cost associated with wireway selection. While a cheaper wireway may save money upfront, a high-quality wireway may last longer and require less maintenance, saving money in the long run. When selecting a wireway, it is important to consider the aesthetic appearance of the wireway. The wireway should be visually appealing and should blend in with the surrounding environment. In some applications, it may be necessary to paint the wireway to match the color of the walls or ceiling. The NEC requires that wireways be accessible. This means that the wireway should be located in a place where it can be easily accessed for maintenance and repairs. The wireway should not be blocked by equipment or other obstructions. The NEC requires that wireways be protected from physical damage. This means that the wireway should be located in a place where it is not likely to be damaged by impact, abrasion, or other physical forces. If the wireway is located in a place where it is likely to be damaged, it should be protected by a barrier or other means. The NEC requires that wireways be installed in accordance with the manufacturer's instructions. This means that the wireway should be installed in the manner specified by the manufacturer. Following the manufacturer's instructions ensures that the wireway is installed correctly and safely. The NEC requires that wireways be grounded in accordance with the NEC. This means that the wireway should be connected to the electrical grounding system in a manner that meets the requirements of the NEC. Grounding the wireway helps to prevent electrical shock. The NEC requires that wireways be labeled in accordance with the NEC. This means that the wireway should be labeled with information about the contents of the wireway, the voltage, and the amperage. Labeling the wireway helps to identify the circuits and prevent confusion during maintenance or troubleshooting. The NEC requires that wireways be maintained in accordance with the NEC. This means that the wireway should be inspected regularly and any damage or deterioration should be repaired promptly. Maintaining the wireway helps to ensure that it is safe and reliable. It's also important to note the availability of different types of covers for wireways. Some covers are solid, while others have ventilation holes. The choice of cover depends on the specific application and the need for ventilation. Solid covers provide better protection for the wires, while ventilated covers help to dissipate heat. In addition to wireways and ducts, there are other types of raceways that can be used for electrical wiring, such as electrical metallic tubing, also known as EMT, rigid metal conduit, also known as RMC, and flexible metal conduit, also known as FMC. Each type of raceway has its own advantages and disadvantages, and the choice of raceway depends on the specific requirements of the installation. EMT is a thin walled conduit that is easy to bend and install. It is commonly used in commercial and industrial applications. RMC is a thick-walled conduit that provides excellent protection for the wires. It is commonly used in harsh environments. FMC is a flexible conduit that can be used to connect electrical equipment to a power source. It is commonly used in applications where flexibility is required. The cost of wireways and ducts can vary depending on the size, material, and manufacturer. It is important to compare the costs of different options before making a decision. Consider the long-term cost associated with the wireway, such as maintenance and replacement costs. The weight of the wireway and its content should be considered when determining the support requirements. The support system should be able to support the weight of the wireway and its contents without sagging or damage. The location of the wireway should be considered when selecting the type of wireway. Wireways that are installed in exposed locations should be protected from physical damage. Wireways that are installed in wet locations should be suitable for wet locations. The environment in which the wireway will be installed should be considered when selecting the material of the wireway. Wireways that are installed in corrosive environments should be made of corrosion-resistant materials. The voltage and amperage of the electrical system should be considered when selecting the size and type of wireway. The wireway should be able to safely carry the voltage and amperage of the electrical system.